Going live.
Going live.
We're live.
All right.
So everybody say hello.
Steve Ski.
I'm not sure if he got the link yet, so let's do that.
Who else is on?
So far, just one person.
Oh, I'm gonna go upstairs and get a drink. I'm not gonna pour inside of it in case it catches fire.
What's there to drink?
We got water last night.
All right.
Okay, hello everyone. This is a live stream from the lab, and we'll be fixing or testing some of the test equipment. So right now we have Fluke 9100 unit. This is a calibrator designed for handheld meters and various low resolution equipment. So as a calibrator can source voltages, currents. I'm not sure if this one can do resistance or not. So this is the opened up cover, and yeah, so I can turn the mic, maybe leave a little bit. Is this better? 1-1. I see the levels kinda low. Let me check the settings. Okay. Should be fine now. How about now? One, two, three. Sound check, sound check. Okay. So I have a few of my friends visiting my lab at the moment. And essentially the idea was to have friends bring their equipment, and we can compare different measurement results. So for example, we have a bunch of Keithley DMMs that we can test and calibrate together and see the stability and all the different performance aspects. But also we have a bunch of resistance standards to calibrate, like Fluke 742. And this is a multiple days meetup, because obviously we will need to have some warm-up for the equipment to reach the stable conditions. So resistors like this, we have maybe 10 or more of them, different values, and this is actually mine, 10 kilo ohm. And also we share all the experiences that we have with different results and measurements, because everybody here visiting have their own labs at home, and essentially we compare and test various stuff. So that's the patient. I have camera in a fixed position, so it's a little bit difficult to move. So we can have some space to actually work on equipment. So it's logistically a little bit challenges, but I can try to show some of the bits. If I can move the camera just a bit. So that's the box. It's kind of beat up a bit, and it have some power issues. So this is the shot inside, and we're trying to power it from the AC source, current limited, just in case something catches fire. And this is a unit under the test, and also we have like bunch of the Keithley stuff over there and all that usual calibration suspects. Todd, say hello to everyone.
Hello, everyone.
Steve is online. Hopefully next time Steve can visit us for the next repair/calfest. So put the camera back in.
Can Steve talk? Can we hear him?
Nope, I think it's only one-way direction, but we can read the chat and reply the questions and do things like that.
Does it overheat? Yes. Will it
Yeah.
take fire? Probably. Where's the flare? Put the flare away.
Yes. You want it back?
We already know what's one symptom that's going on, so it might as well.
Yeah, mic is actually only on me, I believe, so I'll have to translate. It's a small directional micro, and we have the issue with the unit. A couple of the resistors getting very hot, like over 100 degrees, and it's have some trip fault point after the power on check. So the idea is to turn it up, power on, and see what happens.
Really overheating.
And the self-test when it powers on is just going for 10 or 15 seconds or so. And there are some relays clicking and some angry noises of overload can be heard. So the current idea is that there is something wrong with the power supply. But there are huge capacitors, you can see actually on the video on the left. They are 100,000 or 150,000 or so a microfarad, 16 volts. And also there are some high voltage supplies for higher voltage outputs in this calibrator. So it's a little bit dangerous unit to work with. And in parallel, I just have Keithley 2002 finished the performance check. So we'll see how that goes.
Smoking hot. And so are these. I'll get over.
Yeah, right now its unit is powered off. So we're preparing the thermal camera to see if something is overheating.
Not on yet, right? Okay. They look like a bit of resistors, so maybe they meant to be.
6-watt resistors or whatever.
So,
Alright, so what we're gonna do?
Well, you just
Tonight,
yeah, you can toggle the output on the AC source. It's over one over.
Camera going or something? Or?
Yeah, camera is just showing the.
why are you starting without the panel?
There's nothing back there. It won't even know it's disconnected.
Oh,
It's just a dumb circuit
okay,
board.
Okay, I didn't know that. Okay.
Alright, here we go.
So far, so good.
But it's not.
That's why.
Okay.
I have two little lights.
Oh, it looks so good bright.
50, 70,
Yeah, we have 70 degrees, 80,
85.
something getting hot.
Let me see what else is getting hot. That's the important. So these oh look, some here is real hot. Right here. So those transistors.
Yeah.
But that's
About 45. This one
So-
gets hot because that's the.
that regulator is hot.
That seems to be normal.
There are some
Okay.
beeps and some stuff happening. Is it the same fault?
Yeah, now it's going back to the same.
So it says system trip 9508, unexpected power amp overload, program counter 48E3C, whatever that means, and system has been reset. Press resume to start.
Buttons work now.
So the buttons work. There was a stuck button before, and now it's trying to boot up. Says please wait approximately 1 minute for internal checks to be performed.
Yep.
So they're about to disorder themselves.
Yeah. We'll let it fail one more time and then we'll turn it off.
But something else is consuming all that power.
Yep.
So we see a couple of things that are hot.
So the camera angle isn't that great, but I don't have the cable right now long enough to get
Really, especially this one.
in front of the unit.
That would be that one, the left. Oh, that's not even that. That's a transistor that's not attached to heatsink.
You should still be able to pick up the heat signature.
Yeah, so it's that little one. This regulator. Do you have like a wood stick or something, wood dowel?
Can find something.
With this camera, it's a little bit difficult to identify what you're looking at. So if you're poking something with a stick, then you can, in essence. So that's the trick here. Okay. So you know what you're looking at. So sometimes on this camera it's difficult to identify. So those, but they seem like they were supposed to be power transistors. So they're not the load. So those two resistors also quite hot. But I don't see anything
Is that connector getting hot?
that
Yeah.
that transistor was getting hot. Yeah, this one.
Did any of these resistors show hot?
So we're checking with a thermal camera to see if
Not much.
anything cooking.
So it's really this.
I could change to the macro lens.
So that one.
Maybe it will be
This one.
better to have a closer look. Let's try that.
Look where we can so something left to connect. Yeah. That chip is getting hot. That analog device chip.
So that's the close up.
Yeah. So that chip is getting hot. And there's even like some sort of discoloration on it.
Yeah.
Maybe you will tell what that thing is. Also,
So the resistors on the left, they get really hot in there.
can we check the other setting?
No.
So they were in series with some capacitors in a power supply section, and they were really getting cooking temperatures.
Well, I want to keep it on for a couple minutes. Not even that.
Right. So first of all, I can take a look at the residual.
And that's the back of the board. So there is a whole lot of stuff, and it's very kind of Datron looking unit, because it's essentially same guys who designed more popular Datron 1281, 4800 series calibrators, and things like that.
I'm just trying to exclude.
And there is the camera.
So a few things showed up in red, but the top temperature is still 30 or so.
Yeah, doesn't look like something obviously too bad.
So where's my dowel? So this thing is a little hot. One of the caps
I'm an operator now here for the camera.
or these caps.
Siga transformer. It's very popular brand in Fluke and Datron equipment. Like 4808 using the same transformers, 1281, 4950.
I know some op amps run in the 40s, just the high speed ones.
So let me try this.
And this unit have so many fuses. All right.
Yeah, it's the chip. It's not caps.
Well, is it 30 degrees? That's 40 something, 42.
So it's not this side. I don't think so.
Yeah.
Yeah. Okay. Well, at least we exclude that.
Who's commenting?
Who's commenting? Steve says, has Todd checked every fuse?
Oh yeah, all fuses have been checked. Almost all the power rails have been checked, the ones I could find.
Essentially, the idea was to see if all the power rails are good. So we have some of the manual for this unit, and we're trying to compare what is good, what is not. So that's that.
Okay. So this side, this is relatively okay.
Right.
At least we exclude that.
At least nothing gets cooking there. Other than, of course, LM399. This unit is using LM399 as a voltage reference, because that's more than enough stability for 5.5 digit resolution and stability. And you can see those big screw terminals. Those are those capacitors mounted to the board.
Now, the other thing I want you to look at with that, or take a look at,
And
are those green resistors.
Okay.
big nice transformer in center for both high voltage and high current.
Nothing. There's no output.
How are you looking at those resistors? Okay. There's something. But it's not this. Is it the chip between them? Those are two resistors for sure. And the two similar resistors.
Bunch of beeps and relay clicks. And most likely there are some power regulators and high current output stage mounted on this big heatsink, and it blows all the air from there is a fan, and all the air exhaust on the left side of the unit.
Can you see that for a second?
You see, it's helpful, but doesn't have enough resolution or focusing ability to like really see what it is. So,
It gets me pretty close though.
sorry.
It gets me pretty close. Those are the rectifiers that connect to the to those resistors. These stuff's starting to smell cooked now. Smell cooking.
Yeah.
Maybe we can desolder one like one leg of this resistor and just check what's the resistance is. If it's
I can measure it in circuit. It's really damn close to what this
what's the rated value supposed to be?
51 ohms.
Oh yeah, that's low value, so should be easy. Just to see if they are shorted and much lower, or if it's transistors that
So
connected after them.
the op amp that goes real hot is OP 271.
271. Are you sure it's 271?
Yep, 271. Take a look.
What was the temperature getting up to?
Interesting.
It wasn't like really hot.
It's a ceramic package Deep 8 op amp.
So on the camera it looked like it's a connector, but it really isn't a connector. It's not. And the body was.
And I can check the data sheet for it. It's a high-speed dual operational amplifier. Unity gain stable. Of course, it's obsolete. So it's 5 megahertz typical bandwidth.
It's not suffocated, so it would be hard to take it out.
Couple.
Not that hard, but it
And it's rated for, what's the supply?
disconnected.
Supply voltage plus minus 18 volts. Maybe check the supply voltage on it
Okay.
to see if it's even getting the right voltages at the power rails.
I didn't hear that.
Check the supply voltage on that op amp.
Yeah, if it's plus, so the op amp is rated for plus minus 18.
Since you're looking at this, what are the legs for the power?
And it's, let me check, it's dual op amp. And the legs for the power is, well, you will have to find the ground because it's negative supply is 4 and positive supply is 8. So it's
Oh, so it's even like a different.
4 and 8. Pin 4, pin
Oh,
8.
Pin 4 and pin 8. It was like 4 volts and 8 volts.
No. Most likely it's powered from plus minus 15 or something like that. But you will need to find like ground somewhere to reference this bipolar powered amplifier. It has low input offset voltage, around 200 microvolt maximum, low offset voltage drift, and it's a standard pinout for dual op amp, so we can try something, find something similar in the lab and plug it in. Okay, so that's, is it negative or positive?
Minus 14.9.
Okay, so it's close to plus minus 15 volts.
Drop it a little bit. Can you do it one more time? 14.8.
Todd was checking the transistors and few had some strange readings, but there was no obvious like short.
Okay. So the power on it seems okay. Did you?
Can we check on those? You had some questionable transistors, just to see what kind of maybe like voltage or control on the base of them.
It seems to change once you power it on.
Okay.
When it's off, it seems to take the outputs and
Hmm.
short them low. I haven't found the circuit in the schematics, but it seems like that's what it does when it's off. When it comes on, the voltages change.
Okay.
It's a weird thing.
Can you check that regulator that's getting real hot?
Mm-hmm.
Can you see what's the voltage on it? Just to see what it's regulating.
Whoop, sorry about the focus.
There, it's blank.
You need a longer probe or something.
All right, let's see.
11.8.
That's for the front panel.
Okay, so might be perfectly normal.
So it's about 12 volts.
Are you sure that pin was the output? Are you sure that pin was the output?
Well, if it's the input, it's a really bad low voltage for the input. Should be 7812. Oh, it's a tip. Yeah, it's a tip 31.
So the transistor on the heatsink is tip 31.
Test point somewhere in the TP511. I thought I did the TP511. It's way over.
And Todd actually tested all the different power supply rails. If I can focus and remove stuff out of the way.
This is the problem I had. I couldn't find half the test points.
So there are some test points there.
Maybe the rails can check.
And essentially they are showing all the different voltages, but some of them are kind of marked on schematics but not on the board, so it needs some investigative work to find where the test points are.
It seems like the most of the heat is coming from those two transistors.
So while all that is happening, I can try actually to show you calibration on Keithley 2002 that is running in the background. Let's see if I can connect and share the screen. There we go. So this is our in-house software that runs the performance verification for Keithley 2002 against Fluke 5720 calibrator. And right now it's testing DC current. So that is, I believe right now will be 2 amp point, 2 amp range, and 0 current point, then 1 amp, 2 amps, and negative 1 amp, and negative 2 amps. So the full run for Keithley 2002 takes about 9 to 10 hours, and this is a calibration for all the ranges and functions you see on the help list on the right. So the ones marked as green already completed, and right now I have DC current test running. Next will be AC current, and then resistor 2-wire test, and then the report will be generated to calculate with all the uncertainties and pass-fail specs.
I would think if there's something wrong with the rectifiers, the resistors wouldn't be getting hot, the rectifiers would, because they would be shorted together.
Right.
And you can see that somebody's already done their work on here.
Yeah.
And I can't tell whether the model numbers of those transistors are. Who knows if they use the right ones?
Sometimes you would need to remove the board to do that.
I don't know if I can get to it underneath, but I don't think I can.
There's metal underneath, and to take the board out, you would have to take out all of those.
So this pretty much
Yeah.
the interface of calibration software that I've made
Like a socket or something.
to run automated tests.
Beyond that, there's not even much else you'd have to take out. This one wire. Well, these disconnect.
My thought process
That
is take them out one at a time and just.
So right now it's 2 amp range, and actually, as shown in a few previous video, self-heating of the shunt inside of the DMM is actually taking significant time, especially on higher currents. So I have about 30 minutes of sampling to monitor that process, and only take a final like 30 or 50 samples as a calculation for final result on DC 2 amp and 1 amp ranges.
Well, you can just, that's the easiest thing.
And right now you can see delta deviation around 675 ppms of IDL2, and calibrator was calibrated and adjusted just before the test a day ago or so. And actually this is a test run, so we will before any adjustments and freshly after repair on one of the 2002s.
Hold on. I gotta go into the.
Yeah.
And actually you don't see the screen somehow,
Yeah, I gotta go.
I believe.
This one is.
Not all of them show that, but yeah. So when it's off,
So all that explaining was
below the ground.
wasn't for.
No, I understand that this side, the just bolt goes into here.
Can anybody see the actual Windows screen?
But this thing is steel.
I'm not sure. Or is it still showing the camera?
That doesn't sound right.
Trust me, that's what I discovered that when I first opened this up.
But you
That's
see,
like
there
there's-
is like a piece of
we-
plastic here to isolate it, and all of a sudden,
Yeah.
maybe there is one short to the ground, but they are like somehow internally connected. Now they all short to the ground.
Yeah. When you turn it on, you can measure voltages across what those things that appear to be ground.
What you can try to do, if it's that kind of short,
Oh, I see.
you can just
There is a
unbolt
huge
all
delay
right here and just bend them tiny bit.
on the screen that
if
I
it
see.
changes anything.
Okay.
That's a really easy thing to.
Yeah, thought crossed my mind.
So we need just little hacks.
It's kind of weird how this new YouTube stuff works.
These are stars.
They keep updating stuff, and
These are not stars. These are
it's not always updating for the better.
So
This seems like a lot of work to
you can do what?
maybe just need to replace them.
Okay. Well.
What are we replacing now?
Nothing.
Mm.
I bled all over your desk. Sorry.
Uh-oh.
What do they say? Blood, sweat, and tears.
Yeah, the instrument fights back. Yep.
You can see if you look closely at the board, they pulled this relay out, they pulled this relay out, they pulled this one out.
So the idea is to remove the board from the unit.
Pulled this one out, I know that.
So in order to pull one of them
There
out,
are-
definitely we're removing the board. The
Yeah.
board had been removed.
Yeah, they've been replacing relays.
Yeah, there are a lot of stuff to disconnect and untangle
Feel it.
to get access.
Puffed up?
Yeah. I've never seen one of those puffed up before.
Yeah.
It's like it's
possible. Could be, you know, welded shut type of thing.
The way to really check it is flip it over. And
We
check
can
it.
take a look at its temperature, but
Don't see anything. We're looking earlier.
okay. Well, it sounds like you need to remove the board.
So sounds like removable board it is.
Couple of connectors. Lights.
What's about those capacitors? The big ones?
What?
Need to unscrew them
Yeah,
and
go back.
disconnect.
Yeah, we'll try it. We'll try if we can. If there's a way to easily unscrew. We gotta check that they no longer charged. Anything, right?
Well, the capacitors are 16 volts, so there shouldn't be much voltage in them.
Nope.
But there is
1.5 farad.
0.15, right?
0.15. It's the same thing.
10.
0.15 and 0.15 are the same thing. Did I say I was funny?
A little bit.
5/16. Do you have any wrenches?
Yes. Which size?
That looks to be like an 8mm maybe.
5/16.
I have no idea. How much is that?
Try 8
It's a
millimeter.
D. Tronsky.
Like 5/16. Okay.
Ow!
8mm works too.
Oh, there we go.
5/16 is a little tighter.
These are probably only standard parts in this unit.
Probably to get a new modern capacitor in that size would be a couple $100 a piece. They look big and expensive.
Oh, you didn't undo those yet?
I broke them loose. I don't think I've got any turns on them. These headers are polarized.
It's possible because of the deformation. Like you loosen one, it tightens another.
Whoops. I think
Had the washer. The other one did.
What happened?
battery
Back-
died.
Again? We have 7 batteries and none of them are good.
Well, time to replace. Battery number 6.
Just need to find one that lasts forever.
Oh, atomic
I thought you had
batteries.
an AC adapter for that.
Nope.
So not everybody had washers, huh? Some did, some didn't.
Somebody forgot to put the washer back. Most likely this unit was attempted to repair before.
It's an interesting
All
design.
kinds of it, yeah.
So sort of they use that as a long bolt, so it's easier to undo.
Is that heatsink ever get live voltage on it? The big one?
No, I think it's tied permanently to low or ground.
I don't know, but you see all of those transistors, so their bodies, they
Isolated?
they no, they beep to the ground. So even though there are isolators in there, but I get complete short between the bodies of the transistors.
That kind of interesting.
So I I find that odd. So maybe they tied together and one of them is shorted, and
Most likely,
so then all of them are shorted.
I would look at those two that are on the edge with the thermal paste, because the thermal paste doesn't look original. Usually, like when the high power isolation on the TO style transistors is used, often they have like alumina spacer to provide good thermal contact, but have also good electrical isolation. And the thermal paste is obviously not a great mechanically isolative compound there. So we'll try to take the board out and see if there is more options to continue will appear to us. Maybe there is something blown on the backside, or at least can remove some parts and test them. Okay, that was easy enough. That was probably a high voltage supply.
Yep. Different size? Yeah, there's one here somewhere. I put it back.
Ouch.
There's also some sort of short in there that's not installed.
Flip it over, remove it, and allows it to.
All right, I'll leave this running for a little bit.
You gave it everything they got.
There's no patience for people who do stupid shit.
Hold on. So that one is a little connector, or how is this?
That's, no. Pulling from the wrong end, yeah.
Or maybe you have to.
Yeah, sucks.
Let's see if it's. Yeah, I think it's soldered. It could have been a connector, but. Something is still holding us. Oh, it's in the screws. You know what? These two capacitors, I just pressed on them. They were very crunchy on the inside.
Yep.
I would like to think.
Just getting good, yeah.
And here is the. I just started second unit. Let me switch over. There. No, not there. Here. So I have another calibrator with another 2002. So we can run the tests in parallel and save some time instead of waiting for each one in sequence. We can parallel the work by having more test stations.
What else do
And there is some resistance measurement in background with all the interface got messed up, but it's still logging, so I'm not going to stop it. And this is a test of resistance. So here is 1 ohm measurement. Reference is 0.9996976. Just calibrated yesterday. And now actually reading is 9.9 ppm off. It's too low compared to expected value, but this is still well within specification of Keithley 2002, even 24-hour specification. So I can leave this running for a bit, and we'll see from time to time what it's doing.
Staring you right in the face. You don't know they're there.
You're right. And I think then the bolts from the top were bolted into those.
Mm-hmm.
So it's really like a mechanical hold. All the way through. Yeah, it goes now.
What else is missing?
They seem to be moving, at least when I pushed it a little bit.
Something on these ends.
Face?
That seems that way. One more.
And then you have mount screws on heatsink.
No, I don't think so, because right now it's slid that way, all the way. So it should be okay.
What about the ribbon cable that goes to the other board?
There's probably one of these smaller screws that we're missing. It's staring us right in the face.
Smaller screws.
No.
No, no screws.
There is a
Or at least-
slot at
No screws anymore. Okay, so where's the pry bar when you need one? Where is it?
my poor ruler.
It was given a new life.
Well, definitely more useful now.
New profession.
And this goes where? This is
The current output that I was telling you about.
okay, that looks.
Metrology grade spade lugs. People can see them. They're not even gold plated. That's speaker wire that's connected to.
Okay, so we're off here. Yeah, I think
There we go.
I think we're good.
You just need to have the board go through past those slots.
The problem is like this one is gonna be in the way.
Can you remove it?
Maybe, but only once.
Well, the bottom one.
Yeah, I can. Without what's it? I gotta do this. Gotta do that. So now you can remove it.
So the
It's that
kind of.
one after all.
Yeah, seems it's a typical trait of Datron equipment. All these plastic clips and stuff that get brittle after 30 years.
A little bit towards me. Yep, I got this one out. Oh. So what's holding us?
That one back there again.
Okay, okay. You holding it?
Mm-hmm.
We got another one that jumped in right here. Yep.
Looks
Okay.
like it's
You okay
free.
taking it out?
The board is now liberated.
Not quite.
Okay.
You get the ribbon cable back. And the problem is you're going to have to feed it back through somehow.
I guess that
I'll-
zip
I'll-
tie
I'll
probably
take
have to
that
go.
zip tie out. Yeah, I think that's the only way.
This is the way.
Oh boy, zip tie. So that's for some sort of option, I'm guessing.
Oh, look. It's naked on the back side.
Mhm.
And all that flux that's found its way to the bottom side. Look at that everywhere.
Mm-hmm. But nothing tremendously wrong. Yeah, take a look here. You see there is like an insulator in here, but if you don't
Yeah,
put them in the perfect alignment, then the screw, even though there's a seal pad here, the screw could be touching that thing directly. So somebody in one of those places didn't put insulator in properly, and that could be creating a short.
Well, yeah.
Not necessarily this one, but it's a possibility. It's a real one.
Well, then unscrew them all and see if there is a still continuity.
That's exactly what we want to do.
So maybe move the box out and have the board on the bench.
Mm-hmm. Well, I've got the board.
All right.
And yeah.
Transformer is
You
it's a
okay?
trouble. Yeah. Where's it gonna go?
It's kind of light. Could always be worse. So that's the board out.
So all of these are test points. Take a look. 222, 515, 221, 102. So sometimes that's just a point like it would be this one. Sometimes there's a dedicated terminal. That I think they just, not always the actual points, but like this one referring to this one.
Oh, yeah.
So that's probably referring to two legs of that transistor, or we need a number for this, so maybe that number belongs here. Who knows?
Yeah, they jumped around. There's got to be a sheet somewhere where they all cross-reference so you know which one's which.
Oh, so there are no numbers in on the schematic?
There are numbers on the schematic, but they don't. There should be a drawing somewhere where the
Okay.
missing test point should point to.
Well, I guess we need an Allen key to get
Yeah.
this.
Yeah. I'm sure you have
So
one somewhere.
these resistors are very hot, and this one's kinda hot. All right. And those inductors like to cook. It's probably always a typical suspect, 10 ohm capacitor.
I don't think so. It would be red hot if it was a tantalum capacitor.
Well, sometimes they're a little cooking, but not really red hot.
But if they're little cooking, they wouldn't be responsible for that much energy being sucked out of the power supply.
Well, depends on what current that supply is supposed to give.
Get your tools mixed up with mine.
Are these your Allen keys?
This one's mine. I came prepared just in case Elliot didn't have any metric tools.
Haha.
Oh my goodness. Loosen those from
That's
across
star,
there.
that's not a hat.
Yep. Star is not a hex. And of course for bench DMM we will use good old Keithley 2002. Where's the ground?
Hmm?
That? Yeah, it's kind of zero.
Doesn't beep.
That's fine.
No, those are gonna be tricky.
Should design a little beeper circuit that plugs into the digital I/O board, digital I/O circuit port on the 2002, so it beeps. So the resistance is 0.1 ohm, 0.2 ohm, including the wire resistance of the probe.
That's back.
You probably might need to have a couple turns and then wiggle the resistor of the transistor of the heatsink a bit
No,
to see if it changes.
No, you see the short could be through the screw, so I would prefer the screw to be out completely to make sure that we eliminated that possibility.
I mean, you could see even from the DMM if it starts bouncing around, like 0, not 0.
Mm-hmm. Not all of these are fastened the same way. Some of them have the isolators, some of them don't. So you have to remember which ones are which.
Pictures.
Well, picture wouldn't show much.
Well, some have insulated and some don't. You see, this one does, that one doesn't, does. You see the additional. And it doesn't mean that the way they assembled right now is the correct way, so we may have to go and find alternative pictures somewhere.
Oh, I don't remember seeing ever a picture of 9100 before, of insides.
Don't you feel unique, Todd?
Of course they are. They're online. You're joking with me, right? See, you're just losing it just enough. It gets in the way. It won't come out. That's the only one I couldn't get to.
Wow. Since I bought the car, State of New Jersey gave another 2,000 rebate on the Tesla. Like everybody teamed up on making it as affordable as possible.
Just the Tesla or all brand?
I have no idea, but Tesla showed that. They also released the slightly cheaper one without long range, but that's you want to remove the.
I just want to play with it a little bit.
We can go back to testing meter, and we have a couple extra points, 19 kilo ohm, 1 ppm off. And now it's testing 100 kilo ohm, and so far it's trending around 0.9. And yes, it's the final value is plus 0.81 ppm of the calibrator value.
Let's see if we can find a picture.
Now it's 190 kilo ohm. Takes about a couple minutes per each resistance value. And because 5720 can source only fixed value resistances, there are around like 18 or 19 of them. There is no much flexibility in terms of choosing the value to test. So
Don't see much of pictures of that disassembled.
190 kilo ohm is 0.57.
EEV blog article on it, so I took some pictures. They're not very descriptive. I mean, they're not very like all-encompassing of the entire board. Some of them are just shots of here and there.
Anybody worked on 9100 before?
Yes.
Maybe there are pictures online so we can reference. Let's see.
One. That's not the section we're interested in. Maybe another page. There's only one page.
Okay,
You read everything you can.
there is some guy, Martin Miranda, who have the similar unit,
Expected power amp.
and it have actually exactly the same fault.
It's similar, but not exactly the same.
Well, it says 9508.
You read everything on the EV blog about that?
Yeah.
Somebody posting on forum and they say, major update, I have new 22 errors. So
I found the same post.
You guys don't pay attention to anything I send you guys.
nope. 9100, what's that?
You need to sit down. Sir.
Yeah, I don't know.
At least there is some service manual and schematics for this instrument. I'm talking about 9100, unlike more modern stuff. So it helps in troubleshooting and testing.
Did you only have one error, or it's not going any further?
Yeah, it
It's been the same, and
looks
then a couple
out
times it came up. It was
different.
almost like it went past it. Came with multiple error reports.
They probably implemented the way so like if there is something like power critical fault errors, it would lock up the meter, the unit, and avoid having dangerous voltages flying everywhere and probably destroying components, because you can see here, and also the power jumps. So when it starts doing that high voltage or high power test, power goes up to 130 watts or so, but in the normal, like when it's doing most of the relays clicking and stuff, it's about 80 to 90 watts. And when the IEC source was programmed to limit the current, even like 10 amp input current was tripping out on the power on. But that's likely because of the inrush and those big capacitors charge current.
That's possible.
So I had to set up Chroma source to 16 amps maximum current limit to actually successfully boot up this Wavetek 9100. Todd, do you see anything?
Yeah.
There are actually special versions of transistors, packages that are similar in form factor but have isolated tab, but thermally they are much worse than the regular metal tab. And this is typically for like high voltage MOSFETs and components like that. And of course there are industrial packages such as Isotope or the power bricks that often are insulated from the external heatsink in surfaces as well.
Oh, it jumped. When you move that one, there was quite a few jumps. What was the first one?
This one. All three of these are in parallel. This one, and this one are wired exact the same circuit.
When you were wiggling it, that number started to jump.
Looks stable now.
Still short.
Let's take the screws out.
There's no isolator between them, so there's in there.
Oh, so there's no isolator. So that one's supposed to be. So there wouldn't be one of those.
No, I think it was one of these right here. It's not shorted. It's not been shorted anymore.
It's open now?
These two are like this one, 2K. This might have been shorted earlier, and the one next to it, it's 2K.
Okay,
Shorted earlier.
that's a change.
This one here, 2K. 2K. rectifier diodes,
Mm,
and so they're no longer measuring short, which means
that's a good sign.
these have no isolators. So
So we don't worry about those.
They could be connected through the PCB.
yeah.
You can actually buy those insulators from like even DigiKey. They like aluminum oxide or beryllium oxide.
You mean the square?
Yes, because it's kind of a standard part for this style of the packages.
I think Todd said he got mica insulated.
Yeah, that's another alternative.
It's still not
But usually they have lower thermal conductivity than
Yeah.
the.
The other problem is the screw heads. I think they kind of help them clear the body here. The metal, these metal tabs that go up there.
Right. So.
Well, the metal tab probably to spread the force from the screw across the
Mhm.
whole pad, so you don't crack the ceramic insulator. They are not very good to chop steel. This is a meetup RepairFest stream. So we are trying to repair and test old calibrator Wavetek 9100, which have some power supply issues. It looks like. So some of the devices were shorted to grounded heatsink because somebody else was already in the instrument trying to repair it before. And obviously they over tightened the screws or misaligned them, so they get shorted tabs to heatsink. That's what has happened in here. And we took the board out to gain the access for both sides of the heatsink.
Hold on. But they were 2K, weren't they?
No, each side of these are diodes on each side,
Okay.
and this is the counter. That's the connection.
Okay.
Basically, we're just measuring across these resistors.
Okay. Yeah, that makes sense.
And right now I have two friends visiting the lab, so we are testing different equipment, calibrating, measuring, and having fun.
But you see, this one 2 ohm, and this one has an isolator, so it shouldn't be.
Who's upstairs?
It kind of sounds like there's somebody upstairs.
Nobody's supposed to be upstairs, so let's check. Okay.
It was getting hot.
Let's see what's else happening.
Wait, how hot?
I think 60s or something like that. So not white hot, but hot.
A little hot.
So what is that component?
Okay.
This transistor here?
So do you see the model of it?
No.
Take it out.
Hmm?
Take it out. What do we have to lose?
Well, if we have a new replacement of the transistor, we can just put a new one.
Not have it?
You see that transistor, the one that's not bolted? This one.
Oh,
was
okay.
getting hot.
Yeah, unlikely. I don't have much of those packages.
And I don't know what it is.
It's a BD something.
I can look at the microscope.
BD 140 maybe?
Look at the microscope. How can you look at the microscope?
I'm looking at it right
Yeah.
now.
Just look.
Okay, look. He's gonna go
Yeah,
take
good
the
smart
transistor out
asses.
and then look under microscope.
Can you detach the wire?
I could, but it looks like it's connected so well. See? It's cross-threaded itself. It's an X-Dev secret. Probably shouldn't have shown it online. It's a BD 140 or something like that.
It's definitely, it's on semi part. BD either, yes, it's 140.
Sounds
I'm
familiar.
half blinded, I can still see all right.
Well, we can go.
BD like Bobby David.
Yes,
Bobby David, I know Bobby David.
Bobby Dazzler. So there is a smaller SOTS TO package.
The Todd order of BD
Let's
140.
see, BD 140.
Is he thinking that far ahead?
It's a PNP epitaxial silicon transistor,
Wow.
available on Mouser, and medium power linear and switching. It's TO126 case.
Can you beep it with just a diode tester just to see if it's okay?
It's 80 volts, 5 amp, no, 80 volt, 1.5 amp.
Transistor tester or with the diode tester, diode mount, just to see if it's
2002 doesn't have a diode, man. Can you imagine?
right. So
$10,000 meter, you can't miss that.
it's right there. The fluke is right there. Look at fluke.
Oh, no, that's the 87V. I only use this for calibrating other instruments.
I believe we need to power up SMU to test the diode.
No. No, we're good.
Maybe not today. That was a beep. So I brought a second camera.
It's hard to see because they're.
Let's see if I can get it on.
Yeah, so those are shorted together. Yeah,
There we go. I can at least move this around. And it's a little bit small. Let's fix that.
I think it's good.
You think it's good?
Yeah. It matches the other one on the other side with the reverse. So one's NP and the other one's PNP. Unless they're not FETs, right?
There we go. That's better. So what's the plan?
Um,
You got the heatsink not shorted?
for couple components right now. I don't know, we gotta hook it all, plug it all back into the chassis and make sure there's nothing we overlooked.
Right. Did you check the rest of the?
No, no, so we had to go on a.
Yes. Yes.
That's
That was me. That was me. Well, in the end, that board was not that difficult to take out, put back in. I guess.
Screw in adapter.
You want to see how it's done?
What you got?
He got. He got all the accessories to do everything.
No, I mean it's working fine for me.
Okay.
Yeah. That's how I did all these earlier. It's a pain in the ass, but appreciate the help.
Yeah.
Hmm.
What is it?
It's a uni.
Why does it have serial number? That's what that's what I'm curious about.
It's a set of adapters.
I have a similar Pomona branded thing. This might be too. Is that calibrated?
It's always fun to visit somebody else's lab and find all this weird and funky stuff everywhere and hear the story behind them.
I don't know where to check.
I think Todd is trying to speak to us with the hand language.
Yeah. Florida English.
So I'm trying to overlay. Let's see if I can overlay multiple items at the same time. I need to get real close to that 2002 to see the screen.
Probably talking about the obvious thing, but have we checked these three fuses?
Yep. I do the easy stuff first.
Okay.
No, we don't. That was like the third thing I did.
But they're okay.
Yeah. Whether or not they're the right fuses for that spot, I don't know. I'll have to look them up. I don't think they printed anything on these boards.
Some things are made in such an unusual way, like I wouldn't expect fuses to be mounted this way on additional boards.
Well, so you can have access from the top without taking apart everything.
I had a training class where the instructors can only break the machine so much, but they put a bad fuse in, so we went to him and said, hey, we found it's a bad fuse. He handed me a fuse, I put it in, and it immediately blew. And I was like, what? And he's like, you check the value of the fuse you put in? I always check the value of the fuse. I just put in whatever you did. You gotta check the value of your fuse. Instructors report.
Yeah, I'm trying to rearrange this stuff live.
Are they like good knowledgeable or hit and miss?
The one I had in my last class was awesome because he's been doing what
think that works better, so we can see both Keithley 2002 now and main camera.
Check those caps, I guess.
There is a microscope in a way.
All these broken machines we're buying, you think that they would go straight to the passives first, because that's what everybody.
If it has the power, which is the question. Got lucky today.
Yeah, previous setting closed.
Yeah, because it have super cap.
Yeah.
I power it up. It's once in blue moon, so.
This is the only time we can really use them.
Not much activity going on in the chat box, so I guess we can finish up soon. Just on the most interesting part, when all the smoke comes out.
See, if you had Patreon, that's what people would pay for, to see smoke come out.
Electro boom. Boom.
Did you know that all the different chips have all the different smoke? So you can find out what the chip type is by color of the smoke.
Yeah.
Like the power transistors, they usually have blue smoke, and the amplifiers usually have gray smoke.
That'd make an interesting gender reveal party.
You need a smell-o-vision camera.
Smell-o-vision camera.
Yeah.
I know there was smell-o-vision CD-ROMs that you have a special compact disc, and you shoot little tiny capsules with a laser, and then it emits different kind of smells. So you have a disc with a like a smell library, and then yes, when you play the game, then you can have all the different kinds of smell. Depends on the pre-programmed position that laser shoots on the disc. That was back in 2000s or so. Some company repurposed the DVD writer to make a smell generator for computer.
That's creative.
Yeah, but I guess it didn't get commercial traction. Maybe idea for the next generation PC.
Well, the next one should synthesize the smell. Not just release it, you know.
Yeah, somebody is commented. Hands are busy working on my own broken PCB. Enjoying the stream.
And 3. Short. 4.
By the way, the blinking on the Keithley screen, that's due to refresh rate, and I have a lot of lights in the lab right now, but in the reality by naked eye you don't see any blinking on the VFD, so that's just an visual artifact because of the frame rate of camera and VFD overlapping together. Maybe somebody watching now is familiar with 9100 and can give some suggestions in troubleshooting. That would be interesting conversation. Well, I was hoping that would cover some shadows. So while we're doing all that, in background we have 200 volts measurement on Keithley 2002, and it's minus 0.1 ppm from expected to 100. So pretty good.
That's as found on mine.
No, this is the just adjusted Todd Keithley 2002. So essentially, the normal procedure is to have performance check before any adjustments, do the adjustments, and then do the performance check after the adjustment. So we have both reference as found and as returned.
So the difference was only on those three in the beginning.
3 or 4, yeah. Those are the ones I'll check last.
Okay, let's go back.
Nothing shorted at least.
Hello, Supernova 86. We are working on Fluke 9100. It has some power issues, and Todd is currently checking all the power transistors. If there is any short to heatsink, and
This got moist. Let's put it that way.
That's good.
I need to flip this around.
Put it on the caps.
I just want to do the other side of the board.
I thought you already did that. No? No?
Probably did. I want to check these absolutely last.
I think all of these were custom parts they made.
Probably, yeah.
There's no way that that's a count.
and Measurements International 6010B is working perfectly, and it's currently measuring 1 kilo ohm to 100 ohm resistance standards, which are both in chamber. So this is what we use to calibrate all the various resistance standards during this meetup, as well as some other Measurements International bridge, such as 6000A. There will be a report some later date when we review all the data, calculate all the uncertainties, make sure everything is good, and hopefully it will be published sometime this year. So this meetup is actually going over multiple days, because a lot of equipment need multiple hours of warm-up. So, oh, Randy is working on 6010A in the lab. That is interesting. There is not much information about these bridges, and 6010A is, I believe, older version of 6010B, and that was the original bridge that was released back in 90s. So I would be actually quite interested to learn what is different between 6010A and 6010B. So if you can provide any information or contact me by email, team@xdevs.com, I would love to hear more about your 6010A bridge. Is there any problem with it? Does it work? Or are there any faults? Noise. What kind of noise you seeing on the bridge? And also what currents and resistances? Other than going higher than 1 kilo ohm, typically on 6010B, I see the noise within 0.05 ppm or thereabout, but it also can depend on the conditions of the test, like parameter settings, how stable the resistor is, and all the different interference in the lab. So there are quite a lot of things that can go wrong when you're talking about sub ppm measurement.
No, that's not capped.
So we're checking caps.
Yeah.
About 1 ppm, that is why I ended up with it. Okay. What resistance? Because 1 ppm is quite a lot of noise. Many of the modern DMM actually can have similar noise performance on mid-range resistances, such as like 100 ohms, 1K, 10K.
100 microfarad.
I actually had some issue with my 6010B a while ago because of the, I would say, user error, and I had to repair a couple of the items. Okay, 1 ohm to 10 ohm transfer, and I believe that is at 10 milliwatt power. Are you using automated test setup with like GPIB scripts and stuff, or just using the front panel? Okay.
Let's check loops.
Did you try different transfers? And also, I found that with these bridges, the best ratio is around 10. So you would transfer, you would have 10 ohm at RX and 1 ohm at RS. That would usually give the best results.
Hold it up. You want to get to these two, right?
Mm-hmm.
Okay.
Yeah, and my software is pretty nice. It's might have a little dated look, but the functionality of it is great. I use semi software as well for 6000A system.
What frequency you said?
Should be 1K. Yes, 1K. 83 microfarads. Can it show ESR instead of D?
Yeah, you can select the ESR.
Don't have that one, so how do you do that?
You do measurement parameter and
You normally check at 1K or you check it at 120 hertz?
Can you connect? What is supposed to be? 100 mic?
100.
SR, so it's serial should be, so RS should be.
Try change the freq to 120.
120. 100.
120? Yep. Close enough.
So it's 88
Yeah.
and half an ohm. And that one is 88 half an ohm. Okay. Unless they parallel or something. So what's on them?
Huh?
What is the nominal?
100.
100?
Yeah.
I guess 88 is okay.
Probably.
What
So-
capacitors are they? These two?
Yeah, I can't see a voltage rating on them But there's a 70 volt rail here somewhere, a couple of 70 volt rails, so there may be a 100 plus volts and 100 mic.
Yeah, I don't think I have those.
I'll check and see what I brought with me. I think I have some of these.
Using 742A for resistors. Yes, actually, this whole week I was measuring a lot of 742As as well as some other resistors, and yep.
Busy day tomorrow.
Busy day today.
Do you have any CSV file to look at? Maybe, or well, yeah, you have the front panel, so you don't have the data logged. Try to isolate the bridge from the power interferences. Maybe have it on a separate bench or breaker. So if there is anything else affecting the bridge. Does
Power supplies, so if there are old caps, if the power supply is noisy, it might be one.
yeah, for the old equipment, it's a great idea to check power noise and make sure that everything is within spec. So there are 3 power supplies, at least it's 6010B, and I would expect 6010A should be quite similar. Just a sanity check to see if all the electronics getting the good power. Do you have any pictures online of the insides of a version of the bridge? It would be interesting to compare what has changed. Okay, well, let's keep in touch, and maybe if you need some measurements or reference points, I can help you out. Well, we made it better, so we'll just reassemble it back and see if it powers on and give any different errors. But I think the stream is about to finish because we need to go eat something and prepare for Monday. So thank you everyone for stopping by, and see you next time. Bye bye.